All right, welcome back. Today we're going to talk about combinations of functions. And when we're looking at combination of functions, it's important to remember we're talking about combining two different things together. So an f of x and a g of x in different ways. We're going to add them, subtract them, multiply, divide, and do a composition. So let's get right in. When we start to talk about combining functions, we're going to look at the first two functions that we're going to combine. It's going to be f of x and g of x. And something we need to look at notation-wise is if I'm going to add f of x plus g of x, it's going to be written as f plus g of x. And it's going to mean that I'm adding those two functions together. So if I'm looking at adding those two functions, what I'm going to do is I'm literally going to add those two functions together. So I'm going to take f of x plus g of x is equal to 2x minus 3 plus x squared minus 1. So I'm going to add those two together. And when I combine my like terms, I'm going to end up with x squared plus 2x minus 4. That is f plus g of x, or f of x plus g of x. When I go to subtract them, my notation is going to look like this. F of x minus g of x equals f minus g of x. And when I subtract those two, I am going to subtract them. So I'm going to say 2x minus 3 minus x squared minus 1. So I'll be left with minus x squared plus 2x. And then I'll have minus 2, because when I distribute this negative in here, it's going to give me a positive 1 on the end. Product works the same way. When I'm looking at f times g of x, or f of x times g of x, it's going to be written as f of x times g of x equals fg of x. And when I do that actual operation, it's going to be a distributive property situation. So 2x minus 3 times x squared minus 1. And my product there is going to be 2x cubed minus 2x minus 3x squared plus 3. And if I rewrite, I'll have 2x cubed minus 3x squared minus 2x plus 3. And there's my answer. Okay, so it's just a matter of doing the operations that are indicated by this quotient or product or addition or subtraction. My quotient is going to be written as f over g of x, and so f of x over g of x is going to be the same as f divided by g of x. And so when I do this operation, I'm literally going to divide those two functions. So I'll have 2x minus 3 over x squared minus 1. And when I do that, I have to remember to find the domain. So I know that x squared minus 1 cannot equal 0, so I'm going to set it equal to 0 and solve. So x squared equals 1, so therefore x cannot equal plus or minus 1. So that's the restrictions on my domain. So what's my answer? My answer is 2x minus 3 over x squared minus 1. X cannot be equal to plus or minus 1. Okay, so always important to remember that we are working on a quotient. So if I have an expression in the bottom, I have to restrict the domain. That was arithmetic combinations of functions. The next thing we're going to is a composition of functions, and this is a little bit different because we're not going to be looking at adding and subtracting. We are literally going to be putting the function in. Put a function into a function. And so there's an inside, and an outside function. So the second one goes in. So the second one, this means put G into F. And the way that I like to remember it is the second one goes in. Second one goes inside. And so if I'm given f of x is x plus 2 and g of x is 4 minus x squared, if I'm doing f of g of x, let me write f of x. So I'm going to have f of g of x. That's literally what this means. So that means I'm taking my f function, x plus 2, and I am going to put 4x squared, or 4 minus x squared, in for x. And so what I'm going to have is 4 minus x squared plus 2. So literally that function g goes in for x in my first function. And then all I have to do is simplify it. So I have negative x squared plus 6. Okay, so the second one goes into the first one. Let's look at how it's different when I switch them around. So this one's going to be g, and then f of x is going to go to the inside. Well, if I start out with g, I'll have 4 minus x squared, and I'm going to take f of x and literally put it in for x. So I've got 4 minus x plus 2 squared, because I'm literally putting in whatever f is, whatever function f is, I'm putting that in for the x in the g function. So when I simplify this, now this is going to be a perfect square, a trinomial, so I'll have x squared plus 4x plus 4, and I need to distribute this negative sign, so I'm going to have 4 minus x squared minus 4x minus 4, and so things are going to cancel out here, so my 4 goes away, and I'm left with negative x squared minus 4x as my answer. Okay, so in this case we compare those and we note that f of g of x is not equal to g of f of x. Okay, so it's different in this case. So you need to make sure that you note that, because they're not going to be the same. So that's how we do a composition of functions. Last piece is this. We're going to express the composition of this h of x here. Now, what does that mean? Really what it means is if I'm expressing the composition, we are going to make two functions out of it. So that it looks like this. So we are going to make our own composition, and what we're looking for is an outside function and an inside function. Look for and we're going to look for an inside function. We're looking for an outside function and an inside function. Sometimes it's easier to look for the inside function first. Well, I notice I've got this x minus 2 here. So I'm going to make that my inside. And that's going to be my g of x is equal to x minus 2. Well, what that means is my outside function is everything else. So that's going to be the 1 over something squared. Well, because this is an f of x, x has to go in here. So how do I rewrite this? Well, I'm going to say f of x equals 1 over x squared. And g of x equals x minus 2. Therefore, f of g of x is equal to x, or equal to my h of x. Okay? So that's how it is. I just basically decompose the function. That's what we call it. Decompose the function into its two parts. Okay? That's all there is to it, guys. That's composition of functions using arithmetic compositions and also, or arithmetic operations and also compositions of functions. Thanks for watching, and we'll see you next time.